So let's talk about hypothesis and data-driven development. And I mentioned feature toggles because that's one of the major implementation details. So I will incidentally cover a bunch of stuff about feature toggles as well. And then what I'm really talking about here is a new way of thinking about software development, a new way of coming up with ideas for software, some engineering practices that come from the continuous delivery world, including canary releasing and feature toggles, and some ideas around evolutionary architecture, which you've seen some ideas about already. But I want to start with a story from a really incredibly good podcast called Radiolab. And this is not even a technology podcast. It's more, I guess, investigative journalism, but every episode is really fantastic. And this is an episode from February 2015 called The Trust Engineers. And this is about a problem that Facebook had between Christmas Day of 2013 and New Year's Day of 2014. Facebook users uploaded more photos to Facebook than all of Flickr at that time during that week. And a more disturbing problem was that more than 1 million of those photos were flagged as offensive. Now this is a problem for Facebook because part of their mandate is to, anytime somebody flags a photo as offensive, they go and look at it and determine, is it objectively offensive, and if it is, they kick it off the site. And now they have a business problem because they don't have enough staff to handle 1 million photos a week, and extrapolating into the future, this is a really serious scalability problem for them. But then even more confusing, it's okay, don't worry about it.
Sorry, I'm really sorry about that.
Test. Test. Can you hear me now in the back? I'm pretty loud anyway, so better? Can I make it a little bit louder?
Increased. Not this. Collar mic.
The lavalier? Test. Let's use this one. That's fine. So the bigger problem they had was when they started looking at these photos that were flagged as offensive, many of them weren't offensive at all. It was people standing in front of a bonfire on the beach, or a puppy, or a guitar. And I couldn't figure out, why are people flagging these as offensive? Fortunately, Facebook has a really good 21st century DevOps, and they have the ability to do hypothesis-driven development. And they needed to find out why their users are acting the way they are. And so they put out tests side by side to determine why are people flagging things as offensive. And it leads to more questions to get more details. And they discovered all sorts of fascinating things about human nature. For example, they discovered that if you think it's a bad picture of you, you'll flag it as offensive. But it's really subtle, because if you say you look bad in this picture, they'll flag it as offensive. But if you say someone did a poor job photographing you, they're okay with that. Because obviously this photographer didn't know what he was doing, because I looked great that day. So all these little subtle things about wording, and by applying this experiment over the course of about 8 weeks, they narrowed it down to a perfectly manageable set of photos that were in fact offensive. This is that ability to do hypothesis-driven development, trying to learn things from your users that may be impossible to find out otherwise. And we'll see that this has some really interesting applications, particularly on things like mature Agile projects. So let's talk about some implementation details for this. In the early days of Agile, we spent a lot of time getting all this upfront stuff working correctly about, analysis and testing design, etc. But then code went to a really unagile place. It went to operations and centralized QA. This is what was referred to as the last mile problem in software. And one of the things that continuous delivery fixed was made us realize that you can't do those things in batches. All the QA stuff, all the operational stuff, those things need to be done every time you make a change to code. And so a lot of companies pursued this idea of continuous delivery to get more efficient Agile engineering practices. And that's a good outcome all by itself, is more efficient engineering practices. But once you get a bunch of these things in place, what you don't realize is you've given yourself a new superpower that you didn't have before. So let's talk about that superpower. The thing that drives Agile processes is a feedback loop. And more than just a feedback loop, it's nested feedback loops. This is where pair programming and iterations and continuous integration and all those things come in. But one of the things that we've always been lacking in Agile development is getting the user into that feedback loop as well. That's what hypothesis-driven development allows you to do, is incorporate your user finally into your feedback loop for your project. So let's talk about how to implement this. And I'll start in the middle of how you implement this in code. Then I'll talk about how this changes the way you think about things like requirements. And then along the way, I'll talk about some different deployment models that this also supports. So I'm going to start talking about the implementation details by talking about something that's only semi-related, which is the idea of continuous integration. So back in the 70s and 80s, it was really common on projects for developers to work long periods of time in isolation from one another, and then at the very end of the project, incorporate all that code together in this big giant integration phase and get it ready to ship. And not surprisingly, that was a pretty awful process on a lot of projects, and particularly the bigger the project is, the more awful that process is. And that's why in the early 90s, the extreme programming guys invented, among other things, this idea of continuous integration, that we need to integrate constantly. And if you do that, it never grows into this big giant beast that you have to slay at the end of the project, because you handle it kind of incrementally along the way. And this is still a really good idea, but a lot of projects have accidentally thrown continuous integration away. And let's talk about how to get it back. And so the idea of continuous integration is this. I'm sure you're familiar with this idea, but a 1-minute overview. So you have a continuous integration server, you have version control, and you have a developer working on a workstation. You make some changes to code and you run tests, and once those tests have turned green, you then make a pull from version control to pull in any changes other people have made since the last time you synchronized yourself with version control. Do a build here, and when that's successful, you push your code to version control, which kicks off a build in continuous integration server, and when that completes, you have said to have successfully integrated your code. And the mantra that the XP guys created was this idea that everyone commits to the trunk at least once a day. But here's a really common scenario where people have accidentally thrown that away. So let's talk about this common problem. So let's say that you have a code base and you have a main line of development, which is where all the new stuff in the next version is going to be. But there are a couple of things that you haven't decided yet whether you want it in the next version of your code base or not. And so one way to model that from an engineering standpoint is to do feature branching using your version control. And so in this scenario, Professor Plum starts on one speculative feature branch, and Reverend Green starts on the other one, and they start working on these speculative in-flight features. Now, both Reverend Green and Professor Plum know that you should periodically pull from the trunk, because people are still making changes here, and you handle any little merge conflicts that come up there as you pull from the trunk. Maybe a few weeks go by, maybe a couple of months go by, and it's decided, you know what, we love Professor Plum's feature, we want it in the next version of the code base, and so Professor Plum pushes to trunk and performs what we call a merge ambush on Reverend Green, who didn't do anything wrong. He came into work on Monday morning, did SVN up, and now slam. He's got months worth of merge conflicts to handle, which really sucks for Reverend Green. There's a deeper problem lurking here as well, is as soon as you start using feature branching, you have abandoned continuous integration. Remember the rule, everyone commits to the trunk at least once a day? Reverend Green and Professor Plum are no longer integrating their code together, which leads you to this horrible merge ambush. In fact, if you live with feature branches, a terrible merge is somewhere in your future. I was working with a client not too long ago that had an 18-month feature branch that they tried to merge back into trunk and ended up throwing it away because it was going to be easier just to re-implement all the stuff than handle the merge conflicts that they generated after 18 months of isolation from one another. So this is what we don't want to do. Instead, we want a whole bunch of practices around this idea of trunk-based development. My former colleague, Paul Hammett, has done so much writing about this, he ended up creating an entire website devoted to trunk-based development. at trunkbaseddevelopment.com. And there's a lot of really good writing here, including a bunch of stories about a mythical company he calls Bookface and about how they do feature toggles and trunk-based development. So let's talk about trunk-based development, but first let's talk about what's bad about feature branching. There are three bad things about feature branching. The first is the one that we've already talked about, which is the inevitable big scary merge that's waiting for you at some point down the road. But there are a couple of other problems as well. One of them is that using feature branches discourages opportunistic refactoring. If you're living on a feature branch and you realize the customer class is misspelled, you should just fix it and keep going on. But if you're on a feature branch, that's going to make your merge conflict that much worse. And what you're doing is putting barriers in front of developers for the things they should be wanting to do, but now you're punishing them for doing that, and so they just never do it. The third thing that's really hard to do in feature branching is combining features. What if the big boss comes over and says, okay, I want to see the code with just plum, just green, and plum and green go? With feature branching, you have to do all these merge conflicts and manage all that stuff. Using feature toggles, which I'm going to talk about in a second, you just turn on the ones that you want to see together because you've already pre-merged all the code. And so let's talk about this idea of feature toggles and how they address the problems that you get down here about things like, well, what about cherry picking? That's the thing that motivated us to begin with. How can I still cherry pick that stuff and only include the things I want in that release? So we're going to use feature toggles to do this. And in the simplest possible form, a feature toggle is a conditional that says if this toggle is on, execute this code, otherwise execute this other code. So let's think about the green and plum scenario here using feature toggle instead of feature branching. Professor Plum creates a feature toggle and all of his new code goes under his feature toggle. Reverend Green creates a feature toggle and all of his new code goes into that one, but they're all still checking into trunk, which means that as soon as they touch the same file, they get a merge conflict right away, which they manage without waiting months and months and months to handle it. And Reverend Green always keeps Plum's toggle turned off, so he never sees any of that code. And the same thing for Professor Plum, but you can turn them on as you need to if you want to see combined features. So let's talk about how to implement this. And one of my colleagues, Pete Hodgson, has created a really nice entry on Martin Fowler's blog about feature toggles, and I'll use some of his examples. So this is the simplest possible form of a feature toggle. Oh, I went too fast. This is in JavaScript. All the examples here in JavaScript, since that's the universal language now. So let's say that you wanted to create the simplest possible kind of feature toggle. So you have this in your game right now, the reticulate splines function, which is very critically important to any game that you create online. And now you want to try out a new reticulating splines algorithm. The simplest possible feature toggle is just create a variable, flag it one way or the other, and now have a conditional that says, if it's one way, execute this code, otherwise execute the other code. This is very limited and primitive, of course, and so one of the things that you'll probably do almost right away is create a dynamic toggle called a toggle router. So this is a function you can call to say, is this feature turned on or not? And it can return true or false. And this is the idea of creating a toggle router so that you can have multiple spots in your code that can find out should this toggle be on or not, because you may have several different spots in your code base where you need to put code related to that toggle. The beautiful thing about feature toggles, one of the nice things, is it's very easy to test both sides. So here I'm testing one side of the toggle by turning on the thing, and the other one I'm testing it by turning it off, and now I have one cucumber test that can test both conditions of the toggle. I don't have to do any merging or anything like that. All the code is pre-merged for me. So let's talk about building a toggle router. So the idea in feature toggles is you have a toggle router, you have feature toggles embedded in your code, and they refer to this toggle router. It can have some intelligence about the way that it returns values to people. In fact, you can build very selective intelligence into it so that you can, for example, look at the roles of people who are coming in and decide based on that whether to turn a toggle on or not. So one of the things that some of you are familiar with the ThoughtWorks technology radar. A couple of radars ago, we released a piece of advice called Do QA in Production. Now, we're not suggesting that you force your users to become your QA staff, but if you can roll out your brand new code under feature toggles that only your QA staff can get turned on, then you can actually put your code into production and let them QA it and then turn on those toggles later when it comes time for them to for it to go live. One of the things that a lot of companies struggle with is coming up with a realistic production-like environment. It turns out you have a realistic production-like environment called production. So you don't actually need to create another one if you can just use the one you've already got. And I'll show you some of the feature toggle frameworks will let you do things like limit toggles to a particular subnet of your network or a particular ACL that you've defined in your network so that there's no way anybody outside QA can possibly see those things turned on. The advantage of getting code into production aggressively is you can vet the operational characteristics of the code independently from the behavior that it's supposed to have. So let's talk about 4 different uses for feature toggles, including these experimental toggles, which I'll spend a little bit extra time on. And we have these arranged here on a chart with longevity on one axis and dynamic behavior on the other. And on longevity, this goes from a few days to essentially permanent in your code base. And how dynamic it is means that it changes every time you do a deployment versus changing every time you make a request to your application. So let's talk about 4 different kinds of toggles. The first ones I'll talk about are release toggles. Have you ever wondered, so many of you use branches to create release branches. It's a pretty common use for version control. Have you ever wondered how people that do continuous deployment do release branches? They don't do branches, they do release toggles. So now you can create a release toggle. You're still putting your code live into production to vet its operational characteristics, but you're not exposing any of those things to your users yet because you have to turn that toggle on before they can actually see what's going on. And so it's not uncommon to have nested toggles. So you may have a next month release toggle, and under that 4 or 5 other toggles, which are the features that are going to be in that release. One of the feature toggle frameworks I'll show you, you can create groups of toggles and turn them all on or off by one command. So you can build a release toggle. And what this does is this simulates the same thing you'd get from a release branch, but it's way less risky. Because a release branch, you're doing this merge and you're trying to release all this code. For a release toggle, you've already trickle released all that code over weeks and months, and now you're just turning on behavior that wasn't there before, so it cuts way down on risk. So this allows you to do trunk-based development all the way through continuous deployment. It allows you to do in-progress feature verification by things that are not quite done yet, but you can turn them on, for example, for QA. This may mean that you have incomplete or untested code paths that go live, but that's okay. One of our clients is a big financial services company, and they were super paranoid about this idea of feature toggles in production, and we finally convinced them that this is okay by convincing them that, look, the if statement in Java always works. If it doesn't, we've got much bigger problems than doing feature branching and stuff like that. And if I can give you good confidence that everything we're going to put live is underneath something that's not going to be executed, then we don't have any problems. But as soon as we started doing that, now they have the ability to do A/B testing and a bunch of other things that they've really wanted to have for a long time. This may mean you have latent code in production, but that's okay. So one of the other common things that people do is take junior developers and force them to work on a branch, and then some senior developer does a code review and then merges it into trunk. But that's a terrible idea. All you're doing is guaranteeing more merge conflicts than you need. Let them go ahead and check into trunk and then code review it after the fact under a feature toggle. If your developers are so bad that just the act of checking in code breaks your code base, you need to fire them. Because that's bad, but as long as just checking in code doesn't break anything, as long as it's under the toggle, then you don't have to worry about it. And so we're big fans of getting it into trunk as quickly as possible and then vetting it after the fact if you want to. Another kind of toggle, so release toggles change with each deployment. We don't have to be super dynamic with them. Experimental toggles, which are really the thrust of this talk, are extremely dynamic. They will look at the context of the request coming in and decide whether the user should get this turned on or not. This allows you to do multivariate or A/B testing by having 2 different code paths that you can execute. This utilizes a toggle router, and I'll talk about some implementation details for that. The typical lifetime for one of these experimental toggles are hours or weeks, and a lot of this depends on what you're trying to learn and how many users you have. So one of the great things about Facebook is they have so many users, they can find out statistically significant results almost right away. In fact, Google essentially does this to test new search algorithms. What they'll do is create what is essentially a toggle point, and for some 1% of users, you'll get a new implementation of a search algorithm. And if you end up clicking higher on the page than your standard search algorithm, this is viewed as a better search algorithm. The beautiful thing about Google is that 1% of users for them is still millions of people and statistically significant. If you only have 13 users, you need to run your experiment a lot longer before you learn valuable things from it. But that's the point, you want to learn something from it, so that determines the duration of your toggle. And these are extremely dynamic. These look at the context of the request and may turn things on or off based on that. Another common kind of toggle, which are essentially permanent parts of the code base, are operation toggles. Facebook does a lot of this, where their operations group has a set of toggles that are unrelated to application development. They have their own set of toggles, but none of these interact with each other at all. So they use this for operational things, both short-lived things like temporary migrating a data center from one place to another, or really long-lived things like kill switches. They have some code in place that says once we hit a certain level of scalability, we need to switch over to caching rather than not, and there's a feature toggle that does that operationally, so they don't have to do anything physical to make that change. And these tend to live either months or maybe permanent parts of the code base. If it's short-lived, then it may just live for a little while, but it may be a permanent part of the code base. Then finally, the last of these are permission toggles. These allow you to create a kind of a product experience. This is I'll give you a free version of this piece of software, and if you give me some money, I'll turn on some cool extra features for you. One way to implement that is with feature toggles. That way, you know that all the code base works, and it's a unified code base, and you can just turn on whatever toggles you want to turn on for whatever product experience there is. This allows you to have premium versions of your piece of code, or it allows you to do alpha stuff. So I'm a consultant by trade, and it's extremely rare that a problem comes to me that has just the perfect solution on a platter. But this happened not too long ago. We had a client, and they said, okay, here's our problem. They are hosting software as a service, and they have 2 giant clients that only want releases once a year, and they hate bugs. They have another 10 much smaller clients who want a much more aggressive release cycle, and they're willing to tolerate bugs if they can get code faster. How can we possibly manage this complex problem? And it's like, well, duh, you create feature toggles. You turn on feature toggles for the people who want changes and want more aggressive features. You leave the big ones turned off until you turn them on twice a year. Basically what you're doing is allowing your smaller customers to vet your code for your bigger customers, so that by the time you deliver it to them, it's rock solid, which is exactly what they want. And so this is the perfect kind of scenario for them, is to create these kind of feature toggles and then turn them on for some clients and not for others. And these are basically permanent parts of your code base. So when you look at these as static versus dynamic, release toggles tend to be static, where all the other ones have some sort of dynamic element. And from a long-lived versus transient, these tend to be very short-lived kinds of things, releases and experimental toggles, whereas ops and permission toggles tend to take a lot longer. So let's talk about how you implement this stuff, some implementation techniques for feature toggles. So here is a very common little chunk of code. I go and fetch features from somewhere. I create a base email, build email for invoice. If features is enabled for next generation e-commerce, then add the order cancellation content to email, otherwise just return the base email. While this works, it's not very good from a code hygiene standpoint, because now you're making the invoice email code know about order cancellation content as part of the next generation feature set. This is a big burden to put on the people who are creating this invoice email to know all these details about next-gen e-commerce and all that sort of stuff. So there are better ways to organize this so you can get rid of things like magic constants and things like that. So here's one better way to do this. This is the classic version in computer science. So this creates feature decisions for you. We go and create those guys, and now if I have an order cancellation email, then I've gotten rid of my magic constant. And so basically what I've done here is a classic trick in computer science, is just to add another level of indirection, because now I take feature decisions from somewhere, and those can be defined as methods, which are a lot less flaky than strings. But now our invoice emailer is responsible for asking the feature toggling framework how it should perform stuff. And this is generally not a good idea either, because it requires a lot of knowledge about how the next features are going to work in base email. And so the classic way to solve this problem is do inversion of decision, or dependency injection. And so what we're doing here is saying that our invoice emailer takes in configuration. And based on that configuration, it decides what to include or not. And now all of that code is now in this configuration, and it's a lot cleaner than having magic strings all over the place. And again, one of the beautiful things about feature toggles is the ability to test both sides. And so here's one where I test it where it's included, and here's one where I test it it's not. And so because you've pre-merged all the code, it's easy to test both code paths. And one other thing, if you want to do this is the strategy design pattern. If you want to get rid of conditionals entirely, you can use the strategy design pattern, and that cleans up your code a little bit more. So let's talk a little bit more about these experimental toggles. One of the best practices here is to remove these feature toggles as soon as you figured out whether this feature is going to be in the code base or not. It's important to understand what feature toggles are from an engineering standpoint. So when I put my engineering hat on, feature toggles are purposeful technical debt put in place to be able to support the ability to have more than one feature running at a time. It is technical debt, even though it's on purpose, so you want to clean this up as quickly as you possibly can. If you do a Google search on feature toggles, most of the articles are around like this. Feature toggles are one of the worst kinds of technical debt. And every one of the articles that start this way at some point say, we got really excited about feature toggled and put them all through our code base and then got busy doing something else, and now our code base sucks. So basically what they're saying is, we put a whole bunch of technical debt in our code base, and then we were shocked to find all this technical debt in our code base. It's like, well, yeah, that's the way that happens. So the way that we manage this typically is anytime we play a story card that includes a feature toggle, we insert a downstream story card that says remove this feature toggle. It's not scheduled yet, but it is now part of the official backlog, and now the tech lead or the architect is going to aggressively try to get rid of that thing as soon as we can once we've decided what the outcome of the experiment is going to be. Realize that when you use feature toggles, you're going to have two distinct test pathways, and you're going to have to test both of them. This is going to significantly increase your testing burden, at least temporarily, because you're literally testing two completely different code paths, so make sure your testing accommodates that. Another best practice in this world is don't create toggles that depend on other feature toggles, because this is the path to insanity. You'll never figure out what your code base actually consists of. In fact, I've seen a lot of projects that do the same thing with branches. They try to figure out this really Byzantine set of branches, which ones get merged to create a release, and don't do that. That's a bad idea. These tend to be coarse grained, so you don't want 50 little tiny toggles running around. You want 5 chunkier ones running around, and then clean up the ones that have expired. This works everywhere. This works on any platform that has an if statement and the ability to read external configuration, which is pretty much everybody. And it's also ubiquitous. This is used in a lot of places. So I used to do this discussion as part of a continuous delivery workshop I used to do, and the feedback I typically got from this part of the talk was either, man, my mind's about to explode, I can't believe anybody does that in production, or why are you talking about something so old, we've been doing this for a decade now, and everything's fine. So there seems like there's very little middle ground, but this is a completely ubiquitous thing. It's a good idea to take advantage of structured configuration files. I'll talk about toggle routers in a second, but it's a good idea to take advantage of as much verbosity as you can get, because if you create a magic string like this, 6 months from now you're going to go basic rectangle algorithm, basic recreational algorithm, basic recorder algorithm. I don't remember what this was, but if you have some way you can add a description, then you can find out exactly what all these things mean. So let's talk about toggle configuration and building a toggle router. You can do this in a variety of different ways, and none of them are spectacularly better than the other. You can hard code your feature toggles right into your code base. That works for very simple ones, but doesn't scale very well. You can also create basically a map and parameterize your toggles and pass that map around. But you're almost always going to move to a configuration file of some kind, and I'll talk about frameworks that manage this configuration for you in just a second. And help you implement that. If you're using a database already in your application, put your feature toggles there. It's just another form of data in your application, so that's a perfectly good place. Or you can get really fancy if you want and use some sort of distributed asset management tool like Console or etcd or Zookeeper, which are distributed content management solutions, which is elaborate for just feature toggles, but if you are using it for something else, then it's a perfectly good place to put your feature toggles as well. So let's talk about some frameworks that implement this. One of them, most of these are in Java, but I'll show you a list here of a bunch of different supported platforms in a second. Toggle Z is one that's been around for many, many years. It's in its second major release, and we've used this in a bunch of projects. One of the interesting things about Toggle Z is that it implements feature toggles by using attributes in Java, or annotations in C#. The nice thing about that in Toggle Z is when it comes time to clean them up. Because when it comes time to remove a feature toggle, having them based on attributes means you can define usages in your IDE for that attribute, and it shows you the list of all the places where you got that code, and it's easy to go in and strip it out. So having a unique syntactical thing like that that flags each one of them makes them easy to clean up. That's one thing that Toggle Z does for you. The other thing it does is it comes with a filter servlet that you can put in front of your application to manage deployment or activation strategies. So you can do things like username, so you can base it on a username. You can also do things like release date. So if you're using release toggles, you can say, okay, at 9 a.m. on Monday morning, turn the release toggle on. Your users look like you've done a big bang deployment, but you've actually been doing that deployment piecemeal for weeks and months at a time, and just turning all that stuff on. But the one I want to talk about specifically is this one called gradual rollout, because that's actually a DevOps practice called canary releasing. And this lets you manage and model canary releasing. So here's the idea behind canary releasing. You got lots of infrastructure, you got lots of users, and you're about to release a new version that may have some sort of scalability problem or something like that, or may have some sort of negative impact. The idea of canary releasing is let's release this code to a small subset of users first, and then make sure everything works okay, and then if it works, then we'll broaden it or release it to everybody all at once. So this is a common practice in the DevOps world. This is to help reduce risk of release. This is really good for performance testing. But of course, this is the essence of being able to do experimental multivariate kinds of testing, because I'm rolling out a new test version to a small subset of my users. That's exactly what gradual rollout in Toggle Z allows you to do, is to say, okay, I want to gradually roll this out either to a select group of people or just randomly over a set amount of time. And this is a good example of how Facebook rolled out chat. So this is a big deal for Facebook, because they're going to let Facebook users chat with one another, which may have a big impact on their infrastructure. And so the way that they did that was they dark launched all the chat code under feature toggles on all their servers around the world. And then the day they were going to turn on chat, they turned on the feature toggle first for New Zealand. They did New Zealand for two reasons. It's the first country to get sunlight, and they have a relatively small number of Facebook users in New Zealand, so that gave them a good initial spike for scalability. Australia was the next one they turned on. They have more users in Australia. They basically just followed the sunshine around the world, turning on a region at a time, making sure that everything was still good operationally, which allowed them to save the biggest market for last, which is the US, and they rolled it out over the course of 24 hours by gradually rolling out this new feature across their code base. This is an example of the taxonomy. In Toggle Z, you can create a feature group that includes a bunch of other feature toggles and then turn the entire group on or off if you want. Oops, sorry, I went one too fast there. Stop it. So that's the taxonomy. You can create a feature group and then have several different aspects to that guy. So you can turn an entire group on or off if you want. Here's the list I was talking about that included other platforms and technology stacks. So here's 4 in Java. There's Python, there's .NET C#, there's Ruby and Ruby on Rails. There's another one in Java that has a bunch of really attractive enterprisey kind of features called FF for J, or feature flags for Java, including a really nice admin console, which Toggle Z also has. But one of the cool things that FF for J will do is store your toggles either in relational database, JDBC, or something like a Redis cache. You can also use ACLs to define your feature toggles in FF for J. So if you already have ACLs defined for your QA group, you can just say, okay, turn this toggle on for QA and nobody else, and you're done. It also has some nice things like a JMX plugin and some nice reporting and other stuff. So lots of enterprise-friendly kind of features in FF for J. We've used both of these on projects, Toggle Z and FF for J, and both work just fine. Here's an example in the Ruby on Rails world, something called Chili. And the way that you create feature toggles there is by extending a module and then tagging that on to a class or something else. Here's a really simple one in JavaScript through NPM that basically just creates a toggle map for you. And you can check to see if a feature's turned on or not. Here's one in Angular.js, not Angular 2, but this gives you a new attribute in Angular to turn feature flags on or off. And so pretty much any platform that you look for will have support somewhere in it for feature toggles. It's rare to find one now that doesn't. So we talked about the implementation side and the development side. Let's talk about the ideation side and thinking about things in terms of hypotheses. And this was actually, the modern usage of this was coined by Barry O'Reilly in his book Lean Enterprise. The term originally came from an ancient article in Dr. Dobbs' journal, but it had nothing to do with the way we think about it now. And so in Lean Enterprise, he started talking about the way that we capture requirements for things. And he makes an interesting point. In the very early days of software, we used to capture requirements like this. As one of these, I want this goal so that we can receive this benefit. But then gradually over time, we became much more sophisticated and learned about agile development. And so we've ended up with this idea of behavior-driven development and starting capturing our requirements like this, which is way, way better. In order to receive this benefit as one of these, I want this desire. Oh, that's so much better now. Because it's much clear. No, it's the exact same thing. We just reverse the order of the stupid things. This is exactly the same as what we did before. It's this idea that to come up with ideas for your piece of software, you need to have really smart business analysts go in a room and brainstorm stuff and then come up with requirements. That's a form of big design up front. And so what Barry is talking about is this idea of, particularly once you have at least a minimum viable product or a mature code base, you should start casting requirements as hypotheses. We believe that this capability will result in this outcome and we'll have confidence to proceed when we see this signal. So this capability is the thing that we're testing to see if this new capability is going to give us some better outcome than what we had before. And we want this to be quantifiable or qualifiable, and we'll have confidence to proceed when we see this measurable signal. So let me give you a couple of examples of this. So here's an example of a business story cast as a hypothesis. We believe that increasing the size of, one too far again. I don't want to keep doing that. We believe that increasing the size of hotel images on the booking page will result in improved customer engagement and conversion, and we'll have confidence to proceed when we see a 5% increase in customers who review hotel images who then proceed to book in 48 hours. So what they've set up here is say, okay, I want to hypothesize if we make the images bigger, we're going to drive up people actually booking rooms. Let's run the experiment and see if that's true or not. Rather than thinking, oh, well, let's make the images bigger, that'll automatically give us more upkeep or uptake. Let's test that hypothesis and see if it's true. And here's a really common place where this is extremely useful. This is a case study called Hypothesisdriven UX. And this is about a mobile application company in Germany that did auctions. It was a mature application, and this is something that happens quite often in mature applications, that business analysts keep requesting new features. And each feature individually makes sense. When you combine them all together, it starts making for a confusing or hard to use user interface. And that's exactly what happened to these guys. They kept making changes and changes, and then the bad thing happened. Their number of users started going down. And now it started a debate within the company, what do our users actually want out of our application? Do they want more structure? Do they want more listings, or do they want better prioritization? So these are the three hypotheses they came up with, and they ran experiments to see. And it turns out that better structure ended up winning the day. So they released 3 different versions of their application and looked at user uptake and how people were using the application. And it turned out that better structure, ended up being significantly better than the other 2. Now they know what they're trying to build. Without just guessing what they're trying to build, they know what their users want. We had a client come to us who's the number 2 grill manufacturer in the US. And it turns out the number 1 grill manufacturer has a crushingly popular recipe application on the App Store. And so this client came to us and said, we want you to build us a recipe application for the App Store. And we said, really? Because there are a few of those already. And do you know what it takes to become popular as a recipe application in the App Store? And does the world actually need another recipe application on the App Store? And what we realized by talking to them was they didn't have a really good idea of who their users were and what they wanted. And so we actually started doing some experimentation with their users, both in person and through their website. And what they discovered was there are 2 fundamental kinds of grillers. They're the weekend, I just want to get it done as expediently as possible without a lot of headaches kind of grillers. And then the grill fetishists, who really love every aspect and the BTUs and, the special scrapers and all that stuff. And by realizing that, they ended up creating 2 different applications for the App Store, one that optimizes casual grillers and one that optimizes serious grillers. And now they have much better engagement with their actual users because they learned about their users. So their takeaways from this hypothesis-driven UX experiment that they did at this company was take assumptions and state them as hypotheses, buy into those, design according to them, and then force to test against them, and then learn as you go. But here's the really interesting application of this, which is the data-driven development. And I alluded to this a little bit in my keynote. I'm going to give you a bunch more details here. I didn't have time in my keynote. This is from the GitHub engineering blog, and an entry called Move Fast and Fix Things. And this is the problem that they had. So you're all familiar with GitHub. So since day 1, the way that GitHub has merged 2 projects is to shell out to Git command line, have it do the merge, and then suck it back into GitHub. And that works flawlessly because command line Git knows how to merge projects. The problem is it doesn't scale particularly well. GitHub operates at huge scale. In fact, the architect said one of the interesting side effects of GitHub is that every single edge case appears almost instantly because they have so much scale going on. And so now they need to replace merge. Now, GitHub does 60 deploys a day. They do continuous deployment. They actually run their deployments through a chat bot. So you can actually chat with DevOps and say, do a deployment through chat, and it'll go do the deployment, and then come back in the chat window and say whether it was successful or not. So they do continuous deployments on average 60 times a day. And so they wrote a new version of merge as a C library that runs in memory. And now they have to replace merge on GitHub. And this is where those of you who are architects are starting to feel the terror. Because you can't break merge on GitHub. It's worked flawlessly since day one, and we don't want to introduce regressions to merge. That would be bad with a capital B. And so they created this framework and open sourced it called Scientist. And so this is the code that they wrote to execute the new merge stuff. And they wrap that inside Scientist. So let's talk about what Scientist does for a second. So Scientist gives you two code blocks. It gives you a use and a try. The try is the stuff you're experimenting with, and use is the old way it used to be done. And so what happens when it hits one of these Scientist blocks is that Scientist decides whether or not to run the try block or not. For the merge experiment, they did 10% of users would randomly get the try block, and then 90% would get the use block. It randomizes the order in which use and try are run, so you don't get weird patterns in your code. Measures the durations of the runs. It runs both, when you do try, it runs both try and use and measures the result, but always returns use. So the worst case scenario is I got exactly the answer I would have gotten before. But we're measuring and we're comparing results. When we do that, we swallow and record any exception raised in the try block and then publish all this information. So when this went live on their site, they started right away seeing a few conflicts. So these are the number of successful merges. That's almost 3,000. But there are some little blips down here of ones that did not successfully merge. So let's blow up the bottom part of this and see the places that did not merge successfully. So there were 2 that didn't merge successfully there. There's 1 there. 4 didn't merge successfully, so et cetera. So this is the places where use and try disagree with one another, so they can go find why those disagree. But when they roll this out, it looks like performance-wise it's doing what they want to do, because the old code is this blue line and the new code is this green line, so it's clearly much more performant, which is what they were after. But the bugs they found were the really fascinating things to me. So one of the bugs that they found really early on was they realized that when you shell out to get from a command line, as soon as it hits the first merge conflict, it bails and returns. Whereas their code was going all the way through the code base. And so they fixed theirs to return right away the first merge, so that sped it up. They realized that because of the old way they were doing it, they were having to write an index in memory, but they didn't have to write an index to disk, which was expensive, but they don't have to do that anymore, so they could inline that into memory since they're doing everything in memory now. So that fixed one of the performance problems. This is a funky one. If the ancestor had a file with a given file mode, and one side of the merge had removed the file, but the other side of the merge had changed the file mode, Git would return successful merge. This is a bug in Git. So they published a bug report on Git that you've messed up on file modes in Unix. But here's the really interesting one to me. It turns out that since day one on GitHub, files that had 768 merge conflicts came back as everything's okay. Now, as a computer scientist, the number 768 should raise some hackles. Because what is 768 divided by 3? 256. Ooh, why is that number important? Because it's the power of 2. So it turns out what was happening was they were shelling out to this shell script, and if you hit a certain number of merge conflicts, the return value was of a size of an integer that it will roll over the value of the integer back to 0, and 0 means successful. So it turns out since day one, they've had this bizarro bug at GitHub that occasionally files with even numbers of powers of 2, merge conflicts came back as okay, and they discovered this because of scientists. So they went ahead and fixed their old code, even though they're in the process of replacing it, because they'd found a funky, weird edge case bug. This goes back to what I said before. When you operate on the scale of GitHub, every edge case appears almost instantly. And this is one of those weird cases where that edge case showed up. They did find one legitimate bug in their code, which was skipping a step, so they fixed that. After 4 days of iterating on this process, doing 60 deploys a day, they managed to get the experiment running 100% of requests for 24 hours with no mismatches or slow cases, and so they ripped out the old code and left the new code in place. They successfully changed merge on GitHub with no regressions in merge, and incidentally found a bug in Git and 2 existing bugs in GitHub as part of the process of doing that. That's a good example of an evolutionary architecture, making a fundamental structural change to your architecture without breaking stuff in the process. And all scientist really is a specialized feature toggle framework. It's just a feature toggle framework that also does comparisons and other sorts of cleanup to allow you to do these kind of experiments. It ended up verifying tens of millions of merge commits that were identical before they ended up throwing the old code away. This is a great example of the ability to make serious changes to a code base without breaking stuff. And it turns out that scientists has been ported to a wide variety of languages and platforms. There's one in Java called Laboratory. And so if you go to the scientist page, they actually have at the bottom a whole bunch of implementations in other languages where they've implemented essentially the same kind of feature toggle framework that allows you to move mountains in a very safe way while doing 60 deploys a day. So that's this idea of the superpower that you have. It's nice having all these engineering practices like deployment pipelines and feature toggles and canary releasing, but really being able to utilize those as a superpower is a really nice thing. Because one of the things that we have found is that business analysts love the idea of being able to do multivariate testing and find out what their users really want. And this enables that ability. So this allows you to tie in that last feedback loop, which includes the users into our feedback loop. So all we're really doing here, we haven't invented some brand new, incredibly sophisticated thing. All we're really doing is applying the scientific method to software development. You create an experiment, you test that experiment, you look at the results and feed those results back into the next experiment. That's all we're really doing here, but applying the scientific method in an engineering way to software development to learn more, better things about our code. And so particularly with hypothesis-driven development, this allows you to start thinking about ideation in a different way. So you still have your vision and your strategy and your business goals, but at some point, once you reach a certain level of maturity, your ideation process should be coming up with experiments we can run. And that will lead you to a portfolio of experiments that you might want to try, and then you can start running some experiments. You select a few of them and start running them, and maybe one of them does some things really well, but not some other things. And so this is a classic case where you want to do a pivot and start doing more of what they like and less of what they don't like. Of course, these are all driven by continuous delivery and really tight feedback loops. There may be a case of something that looks really promising, but just gets zero user engagement, so you can stop working on that faster rather than put a lot of effort into something that's not going to end up being useful. And of course, the scenario you want is that you start building something and your users really love it. This allows you to double down on it and start building more of what they want and less of what they don't want. This is becoming more and more common out in the world of people using mechanisms like this to learn things directly about their users rather than speculate or just guess. This is a big deal because this ties nicely into the ideas of evolutionary architecture and this dynamic equilibrium problem that I talked about before. Our software development ecosystem lives as part of this dynamic equilibrium that can change any time. And so having the ability to be able to run experiments, to collect data, and learn things about your code base in an engineering way definitely allows you to make better decisions about things. So this is really a new way of thinking about software development. Questions about this? Got a couple of minutes for questions? Yes?
It's more on feature problems than experiments.
Sure.
So sometimes in the world of microservices, it so happens that you get very nasty nested feature problems where someone else does something at the top and some other person does something at the bottom. So how would you synchronize feature problems?
So his problem is in microservices, they get messy nests of feature toggles. Don't build feature toggles that rely on other feature toggles, because that is the path to insanity, as you are discovering. One of the options you have in the microservices world is rather than use feature toggles, use selective routing. So you can put two services side by side and route to one and not the other, and one of them may have a different implementation of that. So that actually gets you away from toggles inside the service and just gets it more at the architectural level. So that is a lot of ways a better way, if you have really good granular services, is do routing instead of feature toggles. Yes? So the good question, what about database schema conflicts? I actually took it out of this presentation because of timing, but it's exactly the same pattern I showed in my keynote, the expand and contract pattern for database refactoring. It works exactly the same way here because remember I said that the requirement for feature toggle is have an if statement and read external configuration. Databases fail both those things. So that's actually one of the tricky places to do this, but you can use native database facilities like triggers to be able to implement this using expand and contract. So that's actually something I want Pramod to highlight more in his book, is how to use things like expand and contract pattern for practical things like feature toggles. But that's the solution. Yes?
Cleaning up part of it has been a problem in my case. We introduced so many features for feature toggles, and then eventually they become about 200. And we didn't check how, because we don't even remember, so we need to use a lot of mistakes or.
So you're saying that you riddled your code base with technical debt and now you're shocked that your code base has technical debt in it. That's amazing. So the problem is people get super excited about this idea and they start chasing it because it's shiny, and then something else shiny pops up and they start chasing that like a squirrel and forget about this other shiny thing. This requires developer discipline to do right. And so we have to be extremely disciplined when you do this, because otherwise you will end up with a code base that is incomprehensible to any human being on earth. Because it has so many feature toggles in it. Because you can't tell what's actually happening here when you have so much confusion. So you should definitely clean up aggressively. So we are super aggressive, particularly experimental toggles. We clean those up as fast as we possibly can because we realize this is purposeful technical debt, but it is technical debt. So we got to clean it up before it gets out of hand. Yes?
Is there a tool that can actually span different database code as well as UI
Yep. So the question is, is there a single tool that spans the database, the UI, the whole shebang? Yes and no. Yes, if you want to buy into a really, really homogeneous platform like Clojure, which has its own database, it has its own code, it has its own UI stuff, you could create really nice unified feature toggles throughout the entire ecosystem by doing that. But that's a high price to pay, is switch everything over to Clojure, including the Clojure database. Most of the feature toggle frameworks that you see here can support multi-language stuff. So you still have to do triggers in the database, so nothing supports that natively, but you can definitely create a toggle router that lives as a distributed service like in Zookeeper and have the JavaScript front end check it and the Java back end check it and the .NET microservice check it to see should I toggle this on or not. And you can actually have toggles that span different technology stacks and have a unified toggle router to do that. Unfortunately, there's not a single turnkey tool that does this, except if you want to go to a unified language stack, which that's a big price to pay to do that. I got time, maybe one more, so you're the winner.
So if we combine feature toggles, say pre-processing code, generate requirements,
processes and not having to build the technical.
Yep. So routing is much better than using feature toggles because routing, you're building a singular thing and just routing to it. But a lot of times you don't have that option. But if you do have the option to do that, I think routing is a much cleaner way to do this than embedding technical debt in your code. Problem is it's hard to do that in monoliths and other things like that. But if you got the option to do routing, routing is definitely the better way to do this because it creates a lot less crufty technical debt that's laying around. All right, well, looks like I've bumped into the end of my time, so thanks very much for coming, and I hope you enjoyed it. Thanks.